Hi everyone, Mr. Boltri here bringing you video 4.3, the last thing that we're going to learn in unit 4. We're going to be talking about tangent slopes, how to draw them and why we draw them. So in order to do this, first we're going to talk about what they are, why we draw them, and then finish up by talking about how we draw them. So as a review of what we've already talked about, we've already learned about linearization. So what is linearization? Why do we do it? And how do we do it? So linearization is taking nonlinear data and changing one of the variables so that when we graph the new variable, it looks linear. So why would we do that? Because when we go through all those steps, it allows us to write the relationship between the two variables. And the relationship allows us to make predictions. Because when it's linear, we can find the slope of that linear graph, and that can allow us to write the equation, which then we can use to make predictions. So how do you do it? You follow the step-by-step linearization guide, which is given to you in class and is available on Canvas, and you can use that for your quiz. So this is a really useful technique, and it's something that hopefully that you understood how to do. And if you don't, please make sure you ask questions for how do you linearize different sets of data. So we're going to learn the same stuff, but for a different method, a different thing, which is calculating the slope of a tangent line. So to talk about what is a tangent line and why we draw tangent lines, I'm going to do a little bit of an example, a real life example with you, talking about the salary that a teacher is making. So the question is, what salary is the teacher making at the 1 year mark? So here we have a graph of the amount of money that a teacher earned on the job and the number of years that the teacher has worked. So annual salary is, in case you didn't know, it's dollars per year. That is annual salary. So dollars per year, that should make us think dollars per year, which is dollars divided by year, should make us think of rise over run. So when we see something that's dollars per year, we should think rise over run. We should think slope. The reason why we wouldn't want to write the equation for this is because if we wrote the equation, it would give us the total money earned. It wouldn't give us the rate at which we are earning money. So when it's asking for dollars per year, the slope, and it's asking for some sort of rate of change, not the total amount. So that's how you would know to do the tangent slope instead of the linearization. So to find the rate at which the teacher is earning money at the 1 year mark, we want to know the slope of this line. So we know how to do slope. Is choose 2 points in the line and then do rise over run. The teacher is making $40,000 per year, which is a pretty good starting salary for a teacher. But what if we look at this graph, the teacher is keeping track of the salary for a total of 6 years now. We see that from 0 to 2 years, there is a certain salary. And then, ta-da, what happens at 2 years? Well, we see that the slope is steeper, which means probably they've been doing a good job and the school gave them a raise. So the slope here is going to be steeper. And then the same thing again happens at 4 years, another raise. So this school is giving a pretty generous raise every 2 years, which that's a pretty good school to be working at. So if the question was, what is the teacher salary at the 3 year mark? That would be right here. So we would want to calculate the slope of this blue section. Now, here's where a lot of people mess up. To calculate the slope of the blue section, you would not take the value at 3 years and connect it to 0, 0. What that would do, that would give you the average salary between 0 years and 3 years. But we don't want the average salary between 0 and 3. We want the salary at 3 years. We want to know how big the raise was, what is their new salary now. And in order to do that, we need to calculate the slope of this blue section at 3 years, not between 0 years and 3 years. So the slope of this blue section is the line is going to look like this. And you'll notice that this line doesn't perfectly match up with the red section or the green section because before they were making less money and then after they're making more money. So we want to know what is the slope of this section. So this dashed line represents basically if they had this salary for the entire time they were working, what would their dollars earned versus time graph look like? So that's kind of what the dashed line looks like. So remember what this dashed line does and how it's working for our next example. But then the same thing we do, we just choose 2 points on our dashed line, which is the same thing as choosing 2 points in our blue section. And we find that the new slope is $50,000 a year. So a nice generous raise for our teacher for all of the hard work that they've been doing. So again, we just found the slope And so finding the slope of this section gives us the slope at 3 years because the whole slope of this blue section is the same. So we didn't actually have to use the point at 3 years, but it would be okay if we did use that point because it would still give us the same slope. It would also be okay if we used points that were not in the blue section as long as they were on this dashed line. It's not okay to use any of the points in the green section or the red section, just all the points in the dashed line are okay because that will all give us the same slope. Okay, that was all to set up. We can find the slope of a linear graph, but what if the teacher plotted their salary over 40 years? You'll notice that all those annual salaries, this is made up of a bunch of little annual salaries, but we can't see any of the individual annual salaries because there's so many years that they all get sort of smushed together. So what we end up with is a curvy graph, which looks like this. So this teacher has been working for a very long time, 40 years, and thankfully they've made quite a lot of money at their job over those 40 years. So teaching isn't a tremendously well-paying job, but if you work for 40 years, then you're going to make some money. So the question is, what is the teacher salary at the 20-year mark? So we know that there is some salary, some rate of change. Remember, we know that we're looking for the rate of change because it's dollars per year. So rise over run is going to give us the slope, but we need to draw the slope of this curvy function right here. So the big question for today is how do we find the slope of a curvy function at one given point? So the given point that we're looking for is 20 years, and what is the slope at that point? And this is where tangent slopes come in. So you've probably heard the word tangent in your geometry class. A tangent line touches a circle only once on the very outside edge. And our tangent line is doing the same thing here, is touching our function only once on the very outside edge of our curve. So you see, this is the tangent line at 20 years, which shows basically how the money earned is changing with respect to time at 20 years. You can sort of see how it is nice and parallel to the function right at that one given point. So now that we have this tangent line, we can calculate the slope of the tangent line by using 2 points on that dashed line. And you could use this purple point right here, but I just chose this one and this one because they were nice intersections for me. And we find that the teacher at 20 years has a salary of $120,000 per year. Now that might be a little bit of an exaggeration, but I needed to make this graph nice and curvy for this example to work. So whatever school this teacher is working at, sign me up because that is quite a bit of money for a teacher to be making. But the important thing is if we draw the tangent line and then calculate the slope of it, it's going to give us the rate of change at that given time. You'll notice that the tangent line over here would be a lot more shallow, meaning that early in their career, they were not making very much money per year. And then later, the tangent line is quite a bit steeper, meaning that they keep getting bonus or raise after raise after raise. And by the end of the 40 years, they're making quite a bit, even more money than that. So, but this is the tangent line at 20 years, which tells us the salary at 20 years. So then now our last big question is, how do we draw a tangent line? There's two main methods, and I'm going to teach you both of them. Different people like doing different methods. For example, I like the first method, and Mr. Taylor likes the second method. They both give you the exact same line, just you get them in different ways. But in both methods, there's one thing in common, and that the first step is always to clearly mark the point in which you're trying to draw the tangent line. So if we're trying to draw the tangent line at 20 years, we put a big dot at 20 years. If we're trying to do 30 years, you want to put a big dot at 30 years. So that lets you know where we want the tangent line to be. Because you don't want the tangent line at 10 years if you're trying to calculate the salary at 20 years. So you put the dot first. And then method A is to take your ruler, and we're going to let this dashed line represent your ruler. You're going to take your ruler or your straight edge, and you are going to follow the curve around until you get to 20 years, until you get to the point that you're trying to get to. So let's look at what that looks like. So I'm taking my ruler and I'm following the curve around until I get to right at 20 years. And this is my tangent line at 20 years. Let's watch that one more time. You see the ruler and you're sort of following the curve around, keeping your eye on 20 years and following the curve until you get to 20 years. And you can see how this is a tangent to or parallel to the curve right at 20 years. So that is my tangent line at 20 years. So you're going to need to practice doing some tangent lines, and you might want to practice with method A and method B to see which you prefer, which is easier for you. Method B is a little bit different, but gives you the exact same result. So method B is you take your ruler and you plop it right down on the point. So your ruler never leaves the point. But all you're going to do is you're going to turn your ruler slowly until it shows the path of the curve, until it is tangent or parallel to that point. So this is what this looks like. If we take our ruler and we put it horizontal, and then we turn our ruler, turn until it looks like it is parallel. And so that is going to be our tangent line. So one more time, method A is the method where we follow that curve around until we get to the point. And method B is where you put the ruler on the point and then you turn the ruler around that point until it is parallel or tangent to the curve. So those are the two options which give you the same tangent slope or tangent line, and then you can calculate the slope of the tangent line by choosing 2 points and doing rise over run. And with all of these things, your number does not have to match my number exactly. It's pretty hard to draw a perfect tangent line. This is the computer drawing the perfect tangent line, so it's perfect. But if your tangent line is a little steeper or a little more shallow, I usually give like a 10% buffer. So if my answer is 50, your answer can be anywhere from 45 to 55, and it can still be in that same acceptable range. So just to summarize the video, tangent slope calculation is drawing the instantaneous slope for a curvy function at a given point. Why would we do that? So we do that to calculate the rate of change or the slope of a function at any specific moment. And the way that you know that the question is asking you to draw the tangent line is you look for words that show that you need to find the slope. So in the example that was given, it was dollars per year. That's rise over run, and that is how we know that we need to find the slope, because rise over run is the slope, and so it's the slope at one given specific moment. So the other thing that would give away that we were looking for the slope in this example was because it said at 20 years. It didn't ask for an equation. It didn't ask between 0 years and 20 years. It asked for at one time, what is the salary, rise over run? So we need to do the slope at a specific time. How do you do it? Well, you draw the tangent line using one of the two methods, whichever works better for you, and then you calculate the slope of that tangent line. Don't forget your units, and then you'll have your rate of change at that time. So to wrap up my video, let's just look a little bit at the difference between linearization and tangent slope calculation. Linearization gives you an equation, and equations are useful in making predictions. But if I want to know how the function is changing at a given time, at a given moment, at a given value, then the tangent slope can tell me how it is changing. So this is useful to tell me what the actual value is, and this is useful to tell me how the value is changing. So it depends on what the question is asking. This question will ask for an equation. This question will ask for some sort of rate or slope at a given value. And that is how you can tell the difference between if the question is asking you to find the tangent slope or if the question is asking you to find the linearized function or equation. So this is Mr. Boltri wrapping up video 4.3 on tangent slopes. We have quite a few practice problems for you to do with your groups, and just know that I am available for you to ask any questions about tangent slopes. Probably the best way to practice, probably the best way to learn this is by practicing, but if you have any questions at all, please let me know, because I want to make sure you feel comfortable and confident with drawing tangent slopes and drawing tangent lines and calculating the slope. But for now, go Bears.